We're going to continue problem solving with proportions. This time, instead of using equations, we're going to use proportions, which, just to refresh your memory, a proportion is one fraction equal to another fraction. Like when we use proportions to write equivalent fractions, like 1/2 equals 5/10, and that's proportion. So that's what we're going to use to solve these word problems. So Norman has a coin collection. There are 2 dimes for every 3/4. Okay, that's important. So when you're writing these proportions, you need to decide which quantity you want to be on the top and which you want to be on the bottom. It doesn't actually matter which way you set it up, as long as you keep it the same way for every fraction that you write in the problem. So I'm just going to set it up the way that it's given. I'm going to put dimes on the top of my fractions, and I'm going to put quarters on the bottoms of all of my fractions in the denominator. Okay, so we have that there are 2 dimes, so I'm going to put 2 on top for every 3/4. So I'm going to put 3 on the bottom. Next to it, I'm going to have another fraction or ratio, but I'm going to be missing something, right? So if we keep reading, we see that Norman has a total of 68 dimes. So where does the 68 go? Is it going to go on the top or the bottom? Well, over here, when I started this problem, I decided that I was going to put dimes on top. So the 68 has to go here. And then my unknown, I'm going to replace with an x. Okay, now let me talk about a property of proportions really quickly, and then we'll come back to this problem. The proportion that I gave you in the beginning was, for example, 1/2 equals 5/10, right? These are equivalent fractions. If I multiply the top and the bottom by 5, I get 5/10, right? Another property that you will see in every proportion is that the cross products are equal. Let me show you what that means. That means that 1 times 10 equals 2 times 5. Right? The cross products are equal. That's what we're going to use to solve this proportion. So we know from this proportion that 2 times x, which we write as 2x, is going to equal 68 times 3, which I'm going to do on my calculator. That is 204. Now we've got a one-step equation, which we're super familiar with solving. The x is being multiplied by 2, so the inverse of that, divide by 2, and we get that x equals 102. So that means, to answer the question, how many quarters does he have? He has 102 quarters. All right, let's try this with another word problem. Sandy uses 3.5 pounds of clay to make 7 small vases. Use a proportion to find how many pounds of clay she will use to make 21 small vases. So again, we've got 2 things that we're measuring, clay and vases. So I'm just going to take them in the order that they were given to me. I'm going to make clay my numerator, and I'm going to make vases my denominator for every fraction or ratio that I write in this problem. Now, it's a little clumsy and clunky to use a mixed number inside of a fraction, so I'm actually going to write this as a decimal. I'm going to write 3.5 instead of 3.5. And you can do that, and especially if it's a common fraction, because we know our common fractions, right? Then it's really easy to write it as a decimal. Okay, so let's set up our first ratio. We have 3.5 pounds of clay. So clay is going to go on the top, And that will make 7 small vases. So 7 is going to go on the bottom. My other ratio, I'm going to be missing one thing and given the other, right? So let's see. It says find how many pounds of clay. So the clay is the part that I don't know. She will use to make 21 small vases. So 21 is my number for vases. Now, you might be looking at this and saying, if I were going to do this with like equivalent fractions, right? Like you have the denominator, find the new numerator. You're looking at the bottom going, well, I know that 7 times 3 is 21. So I have to do 3.5 times 3. That's true. You can do it that way. So if I know that 7 times 3 is 21, I can multiply 3.5 times 3, and I get 10.5. For those of you who are curious and would like to see it done the other way, I can do that. So the other way that you would do it using cross products, if you wanted to write an equation, you would write 7 times x equals 21 times 3.5, which is 73.5. Divide both sides by 7, and you'll get the same answer. All right, but it is okay to look at that and say, oh, that's just times 3. Times 3 on the bottom means I must have multiplied by 3 on the top. And that's fine when that relationship exists. When you can see it like that, that's the best, because then you saw how quickly it like answering that question was, right? It took us no time at all to say, oh, times 3 times 3, right? So either method is fine. I just want to show you both because sometimes there isn't a clear pattern. Like sometimes you can't clearly see what it's being multiplied by. And when you can't see it, then this is the method that you want to choose. All right? Let's look at another one. Quinn is baking sweet potato pies. The table shows the ratio of cups of sugar to number of pies. How many cups of sugar will Quinn need to make 16 pies? Okay, well, I can use any one of these pairs of numbers. So I'm going to use this pair. And again, instead of 1.5, I'm going to write that as 1.5. In the problem, it says it's the ratio of sugar to pies. So that's how I'm going to set up my proportion. I'm going to do sugar as my top number and pies as my bottom number. Okay, so the value that I was given is that 3 pies, so that's going to go on the bottom, is 1.5 cups of sugar. That seems like a really small amount for 3 pies, but we'll just go with it. All right, and 1.5 is going to go on top because that's where I put sugar. In my other ratio, I want to know how many cups of sugar, right? So sugar is my unknown. Will Quinn need to make 16 pies? So 16 goes on the bottom. Now see, this is one of those problems where 3 doesn't go into 16, right? So I can't look at this and say, oh, it's 3 times 5, because no, that's 15. Or, oh, it's 3 times 6. Nope, that's 18. So it's not divisible. So this is where we especially want to use cross products. All right, so let's look at our cross products. We know that 3 times x, I'm going to write it down here, would be 3x. And then we know 16 times 1.5, I think that's 24, but yes, is 24. Right? So 3 times x equals 16 times 1.5, and I get this equation. And then this is a pretty simple one, right? We know that x is being multiplied by 3, so we have to divide by 3 to solve it. And x equals 8. So she will need 8 cups of sugar to make 16 pies. Another way that you could see this relationship, if you're good at like checking out patterns, is you can see that 1.5 is half of 3, and 2.5 is half of 5, and 4.5 is half of 9. So whatever the number of pies is, we take half, and that's the cups of sugar. And that's what we found too, that 16 pies, when you find half of that, it gives you 8 for the cups of sugar. All right, last one. A chessboard is made using the ratio of square length to king's height. Okay, so I'm going to put square length and over king's height. I'll use 2 letters for this one. And it's 1.5 inches to 4.5 inches. Notice that they don't say square length is this and king's height is this. They do tell you the ratio of square length to king's height. So you have to set it up in that order. Remember before I told you it doesn't matter how you set it up? In this problem it does, because they're telling you the ratio of this to this is this number to this number. So the order is important in this one. So we have 1.5 to 4.5. If a chessboard is made with a king's height of 2.25, all right, so think about where that 2.25 is going to go. It's the king's height. So is it going to go on the top or the bottom? Right? It's the king's height. So it's going to go on the bottom. What is the length of the square? So we don't know this. Now, some of my super duper number sense sleuths are looking at this and may be noticing that 4.5 divided by 2 is 2.25. So I could just do 1.5 divided by 2. And that's true. That will get us the answer, just like we looked at before with creating these equivalent fractions. But I'm going to show you the cross products method for those of you who maybe don't always see the pattern, right? This is the method that whether or not you see the pattern, it will always work, okay, 100% of the time. So I'm going to multiply. This cross product will be 4.5. Actually, yeah, I'll do it over here. 4.5 times x, which we just write like that, equals 1.5 times 2.25. And that I'm going to do on my calculator. 2.25 times 1.5 is 3.375. And now we've got a one-step equation to solve. The x is being multiplied by 4.5. So to undo that, we divide by 4.5. I was giving you a minute to think about it, or maybe not a minute, but a few seconds. And then we get, let me divide this by 4.5. I get 0.75. And that's inches because it's asking me what's the length of the square. So it would be 0.75 inches. All right, so yet another method to solve these real-world word problems that have proportional relationships. We looked at how to use graphs, how to use tables, how to use equations, and now how to use proportions and cross products. So if there's any questions, as always, pause it, take a picture, send it to me, and I can help.